Hi everyone, and thanks as always for tuning in. This time we're going to look at the addition and subtraction of matrices and also something called scalar multiplication of matrices. Let's get down to it. So let's take a look at an example and try to add and subtract some basic matrices. So this first example A, we actually have two column matrices, don't we? So to add matrices, all we do is we add the matching elements or the entries. So the order of both of these matrices, if you've noticed, is 3 by 1 and 3 by 1. So our answer is also going to be 3 by 1. To get this first entry, we just add the corresponding entries in the two matrices we started with. 3 plus 6 is 9. And the second entry, 1 plus -5 is -4. And the bottom element or entry is -5 plus 0, leaving -5. So there is the answer, another 3 by 1 matrix with entries or elements 9, -4, and -5. And our second example, we're going to have a similar situation. So here we are actually going to be subtracting two matrices. The orders of these two matrices are the same as well. These matrices are both 2 by 3. 2 by 3. So our answer will also be a 2 by 3 matrix. That is the only real rule when it comes to adding or subtracting matrices. The two matrices must be the same order in order to be added or subtracted. And our answer, let's add the matching or corresponding entries to get our final matrix. 7 minus 11 will give us -4. 1 minus -8 is 1 plus 8, giving 9. And -4 minus 16 will give us -20. Let's take a look at the second row. -6 minus 5 is -11. 0 minus -4 gives +4. Very important to watch out for the negatives because sometimes there are double negatives. It can get tricky. And finally, 12 minus 0 leaves 12. Here's our answer for the second one. Let's take a look at the third one. Ooh. Is there something wrong here?
Obviously.
I think we can't do this.
Do you really think so?
What's the problem with this example?
The two matrices have different orders, so obviously they can't be added.
Yeah, I know. I'm just waiting for the audience at home to try and figure it out, okay?
Oh, okay, get on with it then. I think there might be a problem with him too.
This first matrix here has an order 2 by 2. A square matrix. This second matrix has order 3 by 1. A column matrix. These matrices have different orders, so therefore they cannot be added or subtracted. So what should we write here?
You mean you're stuck here too? Come on, get it together, will you?
Yeah, I know, I'm just stimulating conversation here.
Alright, well stop wasting time then.
Question, should I write no solution here or should I write undefined? Which do you think? Here the question says evaluate. We write no solution when we are solving. Since we are not solving an equation or a problem, we do not write no solution. In this case we write undefined, okay, because it cannot be done. And our fourth example, we have 3 matrices here, getting even trickier. This question involves addition and subtraction of 3 2 by 2 square matrices. So our final answer is going to be a simple 2 by 2 square matrix as well. Let's do it. 5 minus 11 is -6, plus 12 is +6. 8 minus 7 is 1, plus -11 leaves -10. 0 minus -5 leaves +5, plus another 7 gives us 12. And our final entry, negative 14 minus 12 is negative 26. Plus 0 leaves us with that negative 26. There we have it. And there we have basic matrix addition and subtraction. Let's take a look at our second example. Here we're given two 3x2 matrices A and B, and we're asked to perform these two operations here. So for this first one, we are asked to evaluate 5A, which means 5 times the matrix A. Let's just write that out. There we have it in another way, 5 times the matrix A, exactly as it appears there. What this means is we're going to multiply 5 into every entry or element in matrix A, which is simply going to give us another 3x2 matrix as our answer. So let's do it. 5 times 0, 0. 5 times 3, 15. 5 times negative 2, negative 10. 5 times 0, 0 again. And our final 2 in the bottom row, 5 times 4 gives us 20, and 5 times 1 gives us 5. So it's kind of like a distributive rule, isn't it? 5 gets multiplied to everything inside, giving a final answer. When we multiply a number into a matrix like this, it is actually called scalar multiplication. Here 5 is called a scalar number, and it is a number that is not a matrix. In our second part here, we are going to evaluate negative 2 times the matrix A plus 3 times the matrix B. Let's write that out with the matrices A and B there, like so. And this question will probably take us more than one step. So for our first step, let's take care of these two scalar multiplications here to leave us with two simple matrices that we will add at the end. Here we go. Negative 2 times 0. Negative 2 times 3. Negative 2 times negative 2. Negative 2 times 0. Negative 2 times 4. And lucky last, negative 2 times 1. And this second scalar multiplication will result in the matrix appearing right now. There we have it. Let's do the final matrix addition to finish this question. 0 plus 9. Negative 6 plus 12. 4 plus negative 6. 0 plus 24. Negative 8 plus 18. And in finishing, negative 2 plus 36. There we have it. Did you follow along okay? I hope so. So there you have it. Matrix addition and subtraction with a little scalar multiplication mixed in as well. Feeling confident? Then I guess you're ready for a little bit more practice. So please try examples 3 and 4. In example 3, try adding and subtracting matrices in A, B, and C, which is a real long one. And in example 4, you have the matrices P and Q. See if you can use scalar multiplication and matrix subtraction to evaluate 1/2 times the matrix P and the matrix Q minus 4 times the matrix P. As usual, feel free to put your answers in the comments, and thanks again for watching.